Now we see that what are the basic building blocks for designing any network. The first and most important are the nodes. These nodes can be the personal computers or special purpose hardware. They can be the host, they can be the switches, routers, anything which need to be connected. So these are the nodes. The other thing is the links. Links means the connecting cables through coaxial, optical fiber, telephone line. This can be point to point and it can be multi-point access. Now in this diagram we can see that there are 2 points, just these two are connected, that is a point to point connection, and here we can see that we have multiple nodes, they are connected by multiple lines connected via a single trunk node, trunk cable. So these are the links. Now why not connect each node with every other node? Number of computers that can be connected becomes very limited, because if we connect each and every system with each and every other system, then the number of wires coming out of each node, that will become unmanageable. Also, the physical hardware or the devices required becomes very expensive. So the solution is indirect connectivity using intermediate data forwarding nodes. It means that if I want to connect computer 1 with computer 2 and 3, and if I connect computer 1 with 2 and 1 with 3, there will be 2 cables coming out. But if I connect 1 with 2 and 2 with 3, it means that through a single cable these 3 computers are connected, and the thing goes on like this. Next we have switched networks. A network can be defined recursively as 2 or more nodes connected by a link. Then we have the circular nodes, you can see they are the switches, and this cloud environment is a network. So a switched network means that this is a network, the green is a network, blue is a network. These blue, if they want to connect to red, they will use these switches to communicate. If they connect with the green, they will again use these switches. So such a type of network is called as switched network, because these circular switches, they are acting as communication between the nodes. Now as we have seen in the previous slide, that was a network, this is a network, this is a network. All these networks are interconnected with the help of these routers. So a cloud means any type of independent network. So all these networks are interconnected through internetworks. Now components of a network, we can see there are several types of servers. These servers are connected with the client computers through a hub. The hubs are connected through routers with the other networks. So things go on expanding, and finally we reach with bigger networks or the internet. Now what are the switching strategies? There are 2 types of switching strategies: circuit switching and packet switching. The circuit switching carries bit streams. There is a dedicated circuit, and it is exactly the same as a telephone network. The links reserved for use by communication channel, and they are sending and receiving data at a constant rate. As I've told you, the example is the telephone network. Once a circuit is established, whole data will flow on the circuit, and when the network is not desired, the circuit is broken. Another example is the packet switching network, where there is no dedicated circuit. The data is flown by the use of packets or messages. So all the intermediate nodes, they store and forward the messages. They operate on discrete block of data, utilize resources dynamically according to traffic demand. And as in circuit switching, the data flows at constant rate. Here the data follows variable rate and variable paths. An example is the internet. Data packets flow through different directions but reach the destination at one time or some other times, and then they are combined to retrieve all the data. What is addressing and routing? So when we are working on the internet, we need addresses. As we have told you that the data paths are variant, so we need addresses. Also, we need to know what are the different options or the paths through which the data can be routed. So address is normally a byte string that identifies a node. Byte string means it is an 8-bit digital code which is usually unique. And routing means the forwarding decisions. Process of determining how to forward messages to the destination node based on its address. There are three types of addresses. Unicast, when we want to send data to only a single node, this means unicast. Broadcast, when I want to send the data from one client to all the nodes, that is broadcast on a network. Multicast, when we don't want to send data to all the data nodes but some specific nodes, some subset of nodes, then that is known as the multicast. A network can be constructed from nesting of networks. An address is required for each node, and address is used to route messages towards the appropriate destination. Now hosts know how to reach other nodes on the network. All pairs of hosts should have the ability to exchange messages, and as we talked earlier, we want cost-effective resource sharing for better efficiency on the network. The next thing is multiplexing. Now what do you mean by multiplexing? When we have a number of sources and when we have a number of destinations and there is a single communication line between them connecting, so we need multiplexing. In multiplexing, several types of data are switched on a single network line and then it is routed to different resources. So there are two types of multiplexings: time division multiplexing and frequency division multiplexing. Now this is the frequency division multiplexing. So we have the runtime and we divide the frequencies between different users. For example, we have the 4 users and we have divided the frequency among 4 users. So all the data is flowing at the same time, but the users are different and each user has its own frequency. This is known as FDM, frequency division multiplexing. The time is not divided, but frequency is divided. So another example of the time division multiplexing, so instead of dividing the frequency, we divide the time for different users, like this, you see. Now this shows that, for example, if there is a user in blue, its time is finished but the data is not yet finished, then the data is allotted to the green user. Its time is finished, then to the yellow. The time is finished, then to the pink. So the blue user will again get its time and will take the data starting from that time where it stopped. Then we have two types of multiplexing: statistical multiplexing. It is an on-demand time division multiplexing. To save the time, the data will be transferred only when needed, and schedule link on a per packet basis. Buffer packets in switches that are contending for the link. So if, for example, we have different data coming but we have only a single line, so this is a buffer packet which is available in the switch. These data packets will be stored over here and one by one they will be transferred on this link so that there is no congestion available. So we have seen the network totally can be divided into basically 2 categories, and we are talking about the telecommunication networks, the circuit switch networks and packet switch networks. Circuit switch, again we have 2 types,